Namaste to everyone. I welcome you all in my YouTube video channel. Today I will discuss on sum of two tensors, difference of two tensors, inner product of tensor, outer product of tensors, etc. Now we shall discuss on sum of two tensors. As we take here two tensors Aij k and Bij k. These are mixed tensors, each of rank 3. These tensors are in x system of coordinates. Their corresponding values in x bar system of coordinates be a bar ij k and b bar ij k. Let a ij k plus b ij k equal to c ij k and a bar ij k plus b bar ij k equal to c bar ij k. According to the tensor law of transformation, we know that a bar ij k equal to del x bar I by del x alpha. Next, del x bar j by del x beta. Del x gamma by del x bar k a alpha beta gamma. Similarly, b bar ij k equal to del x bar I by del x alpha, del x bar j by del x beta, del x gamma by del x bar k, b alpha beta gamma. Adding left hand side as well as right hand side, we get a bar ij k plus b bar ij k equal to del x bar I by del x alpha, del x bar j by del x beta, del x gamma by del x bar k, a alpha beta gamma plus b alpha beta gamma. Here we have written a bar ij k plus b bar ij k is c bar ij k. So we write here c bar ij k equal to del x bar I by del x alpha, del x bar j by del x beta, del x gamma by del x bar k, c alpha beta gamma, as aijk plus bij is cijk, that is a alpha beta gamma plus b alpha beta gamma equal to c alpha beta gamma. This is the sum of two tensors. Now we discuss the difference of two tensors. Similar to the sum of two tensors, we have taken here two tensors aijk and bij in x system of coordinates. Their corresponding values in x bar system of coordinates is a bar ijk and b bar ijk. Let we take aijk minus bij equal to cijk and a bar ijk minus b bar ijk equal to c bar ijk. According to the tensor law of transformation, we get this result. Also, here we get another result. Now, subtracting to this equation from this equation, we get this value. And here, a bar ijk minus b bar ijk equal to c bar ijk. So here, in place of this, we write c bar ijk. And here also, similarly, this is the difference of two tensors. Now we discuss about outer product of two tensors. Product of two tensors is said to be outer product if a contravariant suffix of one is not equal to the covariant suffix of the other. For example, let aij, k and b, p, q, r be two tensors in x system of coordinates. Here, contravariant suffixes are I and j. Here, covariant suffixes are q and r. So, here we get that no common suffix are here. Similarly, contravariant suffix here is p, covariant suffix here is k, they are different. So no contravariant suffix of first is equal to covariant suffix of second and vice versa. These tensors are in x system of coordinates. Corresponding values of these tensors in x bar system of coordinates be a bar ijk and b bar pqr respectively. According to the tensor law of transformation, we write a bar ijk equal to del x bar I by del x alpha, del x bar j by del x beta, del x gamma by del x bar k, a alpha beta gamma. Similarly, b bar pq r equal to del x bar p by del x l, del x m by del x bar q, del x n by del x bar r, b l m n. Here we have to remember that we have taken the suffix l as dummy suffix. So we may take any type of dummy suffix. In place of L we may write another suffix, but that must be here and here. Similarly, we have taken M. M is a dummy suffix and N is also dummy suffix. So in place of L we may write any suffix that will be here and here also. In place of M we may another any suffix that will be here and here also, and similarly here. Here we take product A bar ijk, B bar pqr equal to del x bar I by del x alpha, del x bar j by del x beta, del x gamma by del x bar k, del x bar p by del x l, del x m by del x bar q, del x n by del x bar r, a alpha beta gamma b l m n. This partial derivative represents contravariant tensors. This partial derivative also represents the existence of contravariant vector. So this type of partial derivative 1, 2 and 3. So the resulting tensor is of rank 3 with respect to contravariant tensor, and this partial derivative represents covariant tensor. This also represents covariant tensor, and this also represents covariant tensor. So the resulting tensor is of rank 3 with respect to covariant tensor. So ultimately we say that the resulting tensor is of rank 6, because here we have 6 partial derivatives, in which rank 3 with respect to contravariant and rank 3 with respect to covariant. Now we will discuss about inner product of two tensors. Now we take Aijk and Bpir be two tensors in X system of coordinates. The product is said to be inner if at least one contravariant suffix of a tensor is equal to the covariant suffix of the second. Here I appears as contravariant suffix and here I appears as covariant suffix. So product of these two tensors is said to be inner product of two tensors. Let corresponding value of Aijk and Bpir be A bar ijk and B bar pir in X bar system of coordinates. According to the tensor law of transformation, A bar ijk equal to del x bar I by del x alpha, del x bar j by del x beta, del x bar gamma, here k is at lower position, so we write here at lower position, del x gamma by del x bar k, and in place of I we write alpha, in place of j we write beta, for k we write gamma. Similarly, B bar PIR is equal to this. If we take product of two tensors, this and this in left hand side and these are in right hand sides. Here we get that these two partial derivatives, here del x bar I is at upper position, here del x bar I is at lower position, that I is a dummy suffix. So we may take these in a single bracket, del x bar I by del x alpha, del x m by del x bar I, then other partial derivatives, del x bar j by del x beta, del x gamma by del x bar k, del x bar p by del x l, del x n by del x bar r, and a, alpha, beta, gamma, b, l, m, n. A bar I j k into b bar p I r equal to, here I is a dummy suffix, so del x bar 1 by del x alpha, del x m by del x bar 1 plus del x bar 2 by del x alpha, del x m by del x bar 2 and so on. That means this is del x m by del x alpha, value of this. We may write this a, alpha, beta, gamma. Next we write these partial derivatives and this, del x bar j by del x beta, del x gamma by del x bar k, del x bar p by del x l, del x n by del x bar r, and b, l, m, n. We may also write this as delta, Kronecker delta, m alpha, a alpha beta gamma del x bar I j by del x beta, del x gamma by del x bar k, del x bar p by del x l, del x n by del x bar r, b, l, m, n. Here Kronecker delta, this is Kronecker delta. If a value of alpha equal to m, then 1, otherwise 0. Here alpha is the dummy suffix. Value of this is 1 for alpha equal to m, otherwise 0. So we do not write the 0 terms, only we write the value of del alpha m equal to 1. So we also write here m, when alpha equal to m, then 1. So this will be m beta gamma del x bar j by del x beta del x gamma by del x bar k del x bar p by del x L del x n by del x bar r b L m equal to del x bar j by del x beta del x gamma by del x bar k del x bar p by del x L del x n by del x bar r a m beta gamma b L m n. So here we see that we get only 4 partial derivatives. This is a tensor of rank 3. This is also a tensor of rank 3. So if it would be outer product, then resulting tensor would be a tensor of rank 6, but here we get rank 4. So rank is reduced by 2 in the case of inner product of two tensors. Now we will discuss about invariant. We have seen contravariant tensors, covariant tensors, that is tensor, and here invariant. Let I be a function of x1, x2, xn. These coordinates are in x system of coordinates. If its corresponding value in x bar system of coordinates is I bar, and if I equal to I bar, then we say that I is an invariant. Now we shall prove that Kronecker delta is an invariant. We know that delta Ij is Kronecker delta, whose value is 1 for I equal to j, 0 for I not equal to j. This is in x system of coordinates. Let corresponding value of this Kronecker delta in x bar system of coordinates be delta bar I j. According to the tensor law of transformation, this equal to del x bar I by del x alpha del x beta by del x bar j delta alpha beta equal to, we get that beta is a dummy suffix. So we may expand this as delta x bar I by del x alpha del x1 by del x bar j delta alpha 1 plus del x2 by del x bar j delta alpha 2 so on, plus let alpha term delta x alpha by del x bar j delta alpha alpha plus dot 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 delta x n by del x bar j delta alpha n. Here alpha not equal to 1, that is value of this is 0. So this term vanishes. This is also alpha not equal to 2. So this will be 0. Here I equal to j than 1 and I not equal to j than 0. So this alpha not equal to 2, 0. Here alpha both are equal, so this will be 1. Here alpha not equal to n, this will be also 0. So we write del x bar I by del x alpha, del x1 by del x bar j into 0 plus del x2 by del x bar j into 0 plus dot 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 del x alpha by del x bar j into 1. It is a particular term, not variable. So alpha is a particular value. So this gives result 1 plus 0 0 dot dot plus del x n by del x bar j into 0. So ultimately we get del x bar I by del x alpha into del x alpha by del x bar j. Here alpha is a dummy suffix. So we get value of this equal to del x bar I by del x bar j. Value of this is 1 for I equal to j. Value of this is 0 for I not equal to j. This is number 1 and this is number 2. So from 1 and 2 we get that value of delta ij and value of delta bar ij be same. So we get delta ij equal to delta bar ij. That is, value in both systems be same, so it is invariant. Now we shall prove that delta ai by del x j is not a tensor. Even if ai is a tensor of rank 1, this tensor is covariant tensor in x system of coordinates. Its corresponding value in x bar system of coordinates be a bar I. According to the tensor law of transformation, this equal to del x alpha by del x bar I a alpha. Differentiating both sides with respect to xj, we get del a bar I by del x bar j with respect to x bar j equal to del 2x alpha by del x bar I del x bar j, this constant. Now this constant, differentiation of this del x alpha by del x bar I, derivative of this with respect to x bar j, as a alpha is in x system of coordinates. So this is the function of, direct function of x1, x2, xn. So we may not differentiate A alpha directly with respect to x bar j. We will have to take these coordinates. So we write del A alpha by del x beta by del x bar j. Here beta be the dummy suffix, so we may differentiate del A alpha by del x1 by del x bar j plus del A alpha by del x2 by del x bar j, and so on. We may write this as del x alpha by del x bar I, del x beta by del x bar j, del A alpha by del x beta plus del 2 x alpha by del x bar I, del x bar j, A alpha. Here we see that in right hand side we have two terms, this and this. The presence of the second term indicates that this does not obey the tensor law of transformation. If this term would not be present, only this single term present, then it would be a tensor of rank 2. So del A I del x j is not a tensor quantity. Thanks for watching my YouTube video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.